So I'm doing something new here. So this is what all the cool people say, right? So you like this? So click like and subscribe. Okay, so on this problem, it is not already changed to the phasor domain. So the first thing we have to do is change all of our components to the phasor domain. And so to do that, we remember that for an inductor, the impedance for an inductor is J omega L, and the impedance for a capacitor is minus J over omega C, and the impedance for a resistor is just R. And you get omega from the function of our source voltage here, the coefficient of the time variable is going to be omega. So omega here is 400. And so our two inductors have the same inductance of 20 millihenries. So that'll be J times 400 times a millihenry is 0.001. And so, I'm sorry, 0.00, sorry, that's not, it's 20 millihenries, not just a milli. So it's 0.02. So times 0.02, so then that becomes J8. And then for the capacitor, I have 1 over 1.6 millifarads, so 1 over 1.16 times 10, so C equals 1 over 1.6 times 10 to the negative 6, so minus J over omega C will be minus J over 400 times 1 over 1.6 times, I don't know why I said 10 to the negative 6, 10 to the negative 3. And that, when you do it, should give you minus J4. And so when we redraw our circuit, we'll have minus J4 for our capacitor, J8 for our inductor, 5 for our resistor, and that's where I have V1, here's where I have V2. And then to change our voltage to the phasor domain, that's going to be 12 angle negative 30. The 400, we used that was our omega. This inductor is the same, it's also J8, and this is 5, that resistance is 5, and that resistance is 5. Okay, so if I wanted to find V1 and V2 using voltage division, then I want to see if I can figure out a total voltage, a change in voltage, say from ground to some other voltage, and the different points along that circuit. And so if I look at say having my V right here, so V is 12 angle negative 30. So that's my voltage source right there. And then on the other side of that is ground. And then I have a 5 ohm resistor. And then from there, if I look at my circuit, like I come up to here and then it splits into two directions. And off on this direction, I have a 5 ohm resistor and I have this inductor of J8. And then I have a capacitor of minus J4. And on this side, I have an inductor of J8 and a resistance of 5. And then back to ground. So my total voltage from here to here, if this is 0, and this is 12 angle negative 30, then I am looking for the voltage right here, V1, and also the voltage right here, V2. So those are the two places I'm looking for my voltage. And so in order to find V1, in order to use voltage division, I have to know the total impedance, and I have to know the impedance of the two parts where I'm breaking it up. So if I want to find V1, then I need to know the impedance of this part. I'll call that Z1. And the impedance of this part, I'll call that Z2. Or in other words, just looking at our circuit over here, the impedance of this, and then here's V1, and then the impedance of everything else. And I also need to know the total impedance. So I'm going to start by finding the impedance of, I'll call this ZA. That'll be the impedance of the 5 ohm resistor and the J8 inductor. Those are in parallel. And so since they're in parallel, I can do product over sum. So that'll be 5 times J8 over 5 plus J8. Which is J40 over 5 plus J8, which is so J40 divided by 5 plus J8 is 3.596 plus J 2.247. And then if I look at the way I drew it over here to kind of conceptualize it, I can say that this part is in parallel with this part. So now I'll call ZB the impedance of this side over here. So ZB equals ZA plus minus J4. Well, that's real easy. I just have to add minus J4 to that. And that gets me 3.596 minus J4 1.728. Okay, so that was the impedance of this side. Now the impedance on this side, I'll call that ZC. That's real easy. There's just two things in series. So that's just 5 plus J8. So now, to get the impedance of all of this together, then I would say the impedance of that whole bottom part is going to be ZB in parallel with ZA, which will be 3.596 plus J. Was that a phone or some? Yes, 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 thank you, with ZC. So 3.596 plus J 2.247 times 5 plus J8 over 3.596 plus J 2.24 plus 5 plus J8. I did, and I did that the first time I did this on my when I was working it out as well. Thank you so much for catching that for me. It should have been minus $1.728. And I have written down that I got this to be 3.542 minus 0.2 minus J 0.2483. Why don't y'all check that and see? That's what you got? Okay, good. Okay, so that's the impedance of the whole bottom part. So now going back and looking at our original circuit, let's just review what we did The first thing we did was cast everything into the phasor domain. Then we found these two in parallel, and then we found those in parallel plus this in series, and that got us this side. And then this side was these two in series. And then we found this whole side and this whole side in parallel. And that is the dividing point between the 5 ohm resistor and everything else. So to do voltage division to find V1, we've got, essentially what we've got is our total V, which was 12 angle negative 30, 12 angle negative 30. And then we have this impedance, which is, then we have a 5 ohm resistor. And then we have this impedance, which is 3.542 minus J 0.2483, and then ground there. So to find V1, which is right there, V1 is going to equal this, the total change in voltage from here to here, which is 12 angle negative 30, times the impedance from 0 to V1, which is 3.542 minus J 0.2483, over the total impedance. And the total impedance is just the sum of the two impedances. I didn't calculate that separately because it's real easy. It's just a resistor, it's just 5. When I add it to that, it just turns this to an 8. So 8.542 minus J.42483. So just to show y'all to actually do a calculation. So on this calculator, the one I recommend, open parentheses 12, and then second complex angle -30, close parentheses, times fraction 3.542 minus J.2483 over 8.542 minus J.2483, and I get 4.212 minus 2.66 minus J 2.667 or 2.668, and then to change that to polar, I can do second complex change to r theta, and I get 4.986 angle -32.3. Okay, so that got me V1. Now let me go back and look at my circuit and see what else I was supposed to find on this. I was also supposed to find V2. So to do voltage division on V2, instead of using the whole circuit, I'm going to want to use just this part of the circuit, because I know what V1 is now. And so if I look at just that part of the circuit, then the top is V1, which is 4.986 angle -32.3 degrees. And then what I have, this part right here, that's what I called ZA, because that was just the 5 ohm resistor and the 20 millihenry inductor. So this was ZA. And then I had my capacitor, and then from there it goes to ground. And ZA we had was, is this correct? 3.595 plus J 2.247. And this capacitor was minus J4. Is that what we had? Okay, so to do voltage division, what you need to have is the total change in voltage from one point to another. I've got that. And I need to know the impedances on either side of the point where I'm looking at. And I'm looking at V2, which is right there, which in my original circuit is right here. So this is my ground. This is the point that I know. This top part is ZA. The bottom part is that capacitor. And so V2 will equal my total voltage, 4.986 angle -32.3, times the impedance from 0 to the point that I'm looking at, which is minus J4, over the total impedance, which is these two impedances added together, 3.596 plus J 2.247 minus J4. So I can take the answer that I had before times, and then a fraction minus J4 over 3.596 plus J 2.247 minus J4, and I get minus 0.552 minus J.9546. And if I change that to polar, I get 4.985 angle negative 96.35. I just wrote negative 96 degrees. And then the original problem said then find IC. And the reason I did that is because the circuit I copied this from, the book I copied it from, the problem was to find IC. And so the only way I could check my answer was to actually find IC. And so we'll just go ahead and do that because it's good practice. So IC, but it's easy to do now because now I can just use Ohm's law. And so Ohm's law tells me that V equals I times Z, or I equals V over Z, where V is the change in voltage from the two places, and Z is the impedance between them. And so I know all that now. So I equals V, which is the V I just got, which was 4.986 angle negative 96 degrees, over the impedance was minus J4. So it was the answer that I just got divided by minus J4 in parentheses, because if I don't put it in parentheses, it'll divide by J and then multiply by 4. And I get, I did not write this down, I just checked to make sure that it was right, 1.239 plus, or minus minus J.138, or change that to polar. (1.25) angle negative 6.36. And then I asked the question, how would you find V3? So can y'all tell me how you would find V3? It would be pretty easy. Yeah, so you do it the same way we kind of did the V2 over here. You'd start with V1, which would be the total voltage difference from here to here. And then you'd multiply that by the 5 ohm impedance. I'll just write it here real quick. I'm not going to actually do the calculation because that's where I make mistakes. So V3 would equal V1 times 5 over 5 plus J8. Okay, any questions on that one?
Ready?